This question asks us to integrate 2x plus 3 all to the power of 4. To do this, we're going to use our knowledge of basic integration rules along with our knowledge of the chain rule for differentiation. So to start off with, we're essentially going to take a bit of an educated guess. So remember, if this is the derivative, when we're integrating, we're essentially finding the original function, or y equals. So I know that the original function will need to be to the power of 5, because the first integral rule that we learnt was that you add 1 to the power. So I can say that y equals 2x plus 3 to the power of 5. Let's take the derivative of that and see how close we are to this actual question here. So differentiating with respect to x, we need to use the chain rule. So it becomes 5 multiplied by 2 because we find the derivative of this one here, outside of 2x plus 3 to the power of 4. Simplify that and we've got 10 outside of 2x plus 3 to the power of 4. So you can see how close we are to the original one when we derive this. The only difference being is we have a constant of 10 out the front. So we can make a bit of a statement now, and we can say that the integral of 10 outside of 2x plus 3 to the power of 4 is equal to 2x plus 3 all to the power of 5 and plus c. Let's not forget about our constant. So in order now to find the integral of this one, because we know that this is very close to this except for the 10, essentially what we can do is we can divide by 10 to cancel it out. Because of the equal sign, what I do to one side, I will need to do to the other. So I can have my final answer that the integral of 2x plus 3 to the power of 4 is equal to 2x plus 3 to the power of 5, all divided by 10 and plus our constant. And that there is the answer. Just a quick note, you may also see this one sometimes written as 1/10 multiplied by 2x plus 3 to the power of 5 plus c. They're both exactly the same, just two ways of writing it. Feel free to watch on. I'll do another example. The more examples you do or questions like this, you will start to see that pattern and you will be able to recognize what the integral should be. Okay, if you're still with me, let's take a look at this one now. This time we've got a constant out the front already. Again, from what we've learnt from our basic integration rules, we can take that 4 out the front and it becomes 4 times 3x minus 2 all cubed dx. So for the moment, I'm going to just ignore this 4. I'm not going to forget about it completely, but I'm just worried about this one for now. Again, we know that this is the derivative and we want the integral. So we can say that y equals 3x minus 2 to the power of 4. So if I derive this, I get dy, not dx. dy dx is equal to, again, we're using the chain rule, 4 times 3 outside of 3x minus 2, okay, to the power of 3. So I've got 12 outside of 3x minus 2 to the power of 3. Again, you can see how similar these both are with the exception of this constant. So I can make a quick statement and I can say that the integral of 12 outside of 3x minus 2 to the power of 3 dx is equal to 3x minus 2 to the power of 4 plus c. All right, but we don't want 12 times this, we just want this. So in order to get that, we'll divide both sides by 12. Now I told you that I wasn't going to forget about this 4, so let's bring him back in as well. So now I've got 4 times, okay, x minus 2 cubed dx is equal to 4 times 3x minus 2 to the power of 4 divided by 12 plus c. This can obviously be simplified further. So we're left with 3x minus 2 to the power of 4 all divided by 3 plus c. Again, remember, you might find it written as 1/3 multiplied by 3x minus 2 to the power of 4 plus c. Try and practice some more. Like I said, you should start to see that pattern forming, and that's how we come up with that basic rule. In fact, if you want to keep watching for another 30 seconds, I'll write that basic rule for you now. So as we know, the integral of ax plus b to the power of n is equal to, oh, I forgot my dx, sorry, dx is equal to ax plus b to the n plus 1 divided by a times n plus 1 plus c. And there you have it. Go and practice some on your own.